how to use Pandas. This is a very powerful tool for data analysis. So in the previous videos, we've seen other data types like dictionaries, lists, and whatnot, integers, and so on and so forth. Well, Pandas takes that and uses those basic data types to create larger data types that can do a lot more in terms of data, and we're going to see those. Now, Pandas doesn't come standard with Python, so you have to import it. When you start working on Python, it doesn't just show up, so you have to import it. And we do that by using the command import pandas. Now, we're going to have to reference the pandas library a lot. So we're going to shorten its name by saying SPD. And then every time we need something from pandas, we're going to do pd dot something. That's how you reference something that's in a library. So the first thing we're going to do is we're going to create a structure. Pandas treats files and data as if it were like a spreadsheet. So we're going to create one of those by hand. So I'm going to create a database of employees, for example. So I'm going to call it emps, and it's going to be a data frame. Data frame is a data type that it's available only on pandas. So I have to do, so it only belongs to pandas library. So I have to do pd, because that's the name I gave my pandas library, and then data frame, open and close parentheses. This will create an empty data frame. We can think of a data frame as an empty Excel spreadsheet, if you will. Okay, so now I'm going to fill it up. So what I will do is first say the name of the database, emps, and then in square brackets and quotes the name of the column that I want to put. So first, for example, the first name is going to be column. And then I will assign this just like I do on a dictionary. A clue to see the previous video on dictionaries. But I will assign all the values in a list. So my names are going to be John Lennon, for example, Janis Joplin, Carole King, and Elton John, for example. Let's say those are my employees. Now, I'm also going to have a column that tells me how many years they've been working for the company. And that's also going to be a list. Now, this list has to have the same number of elements of the employees, because every employee will correspond to a number of years in the company. So say John Lennon's been with the company for 12 years, Janis Joplin for 15 years, Carole King for 34, and Elton John's been only in the company for 2 years. I'm also going to add another column called age, so how old they are. And they're going to be John Lennon's 52, Janis Joplin 75, Carole King 74, and Elton John is 68, for example. These might not be real ages at all. Now, another column, and maybe my last column, is going to be what's the salary of each one of these employees, right? And the first employee is going to have a salary of $54,900, for example, $34,200, $38,500, and $51,200, for example. Let's say those are their salaries. This is a data frame, and then I can print this data frame, and we'll see how this turns out. So I'm going to execute this code, and here I see my table, my little table with the name, years, age, and salary of these employees. These are the names, these are the years, this is the age, this is the salary. Okay, now one thing we can do is select just the values in one column, and we do that very much like a dictionary. So if I do this, for example, I'm going to select the age of my employees. I'll select a column. See, now here in age, I have 52, 75, 74, 68. That's the age. Now I got some other additional information. So the name of the column is age, and the type, the data type of this column, so the data type of these values is an integer. Integer 64 basically means just a very big integer. It can go to very big values. But these are integers. Now, I've selected a column. What if I want to select a row? So let's select this row, for example, here. This is row number 2, row start at 0. So in order to select a row, or let's select row number 1, where Janis Joplin is, okay? I would do emps dot loc for a location 1. So this means select from emps the row number 1. And here I have it, Janis Joplin. See, this is row number 1. You see the number 1, the Janis Joplin. But now here I have it with its value. So name is Janis Joplin, years is 15, age is 75, and salary is 34,200. Okay? Now, the row is different because the data types of each one of these columns is different. So I will get the name of the column is column 1, and then the data type is, it's just going to say it's an object. It's a column. It contains many objects or many data types. Okay? Now, if I want to get some information on this table, I can also do the following. On the whole table, I can say print, because I'm going to print this information, emps.info, open and close parentheses. If I do that, I will get a few things here. Here's my table, right? So first, it tells me that it's a data frame, okay? That it has 4 entries, and the entries go from 0 to 3. There's 4 columns, okay? And the number and the column names are name, years, age, and salary. Now, how many non-null? So how many values are under name? There's 4 names. There's 4 years, 4 ages, 4 salaries. And what kind of data type they are? Well, the first one is a name, which is a string. Here it says it's an object, which is basically a string. And then the other ones are integers. It tells me that there's 3 objects, 3 columns of data type integer, and 1 of data type just generic object. It tells me how much memory it's using as well. So this is a little bit of information on the table. Now imagine you have to create a database. This is a painful way to create a database. This is just to illustrate what databases might look like in Pandas. Now let's load some file, okay? So for example, I'm going to create, I have a data file in my computer that actually has information about wildfires in Los Angeles. And this is the file. I'm going to load it. So the first thing you need to do is go to where you have your data. And on Windows, you'll see a button here at the top that says Copy Path. Click on that. If you have a Mac, I believe you can do the same thing by right-clicking on the file and say Get Info, and then you can copy the path. So I've copied the path of this file, and I'm going to use it in a second. In order to read files, you will do, for example, I'm going to create a data frame. I'm going to call it DF because I like originality, and DF stands for data frame. And I'm going to read a CSV file, a comma-separated file. Okay, it's important that it's a comma-separated file. So I will say PD, because this is a Pandas function, read CV, so CSV, I'm sorry, read comma-separated file. And here in parentheses, I have to say which file. So what I'm going to do is I'm going to type an R, and then I'm just going to paste the path. Okay, R and paste the path. That will read this file. Okay, so for this one, I'm going to load the file CWD2, okay, data file. So I can make comments in Jupyter Notebooks. We've seen that before. So I'm going to read this file into a data frame here. So instead of creating every row, every column, and then every row one by one, I can just load them from a comma-separated file that I already have. And what I can do then with that is to print the first, say, 10 rows. So I can do print, and this is my data frame. All my data is there. DataFrame.head, and then the number of rows that I want to print, 10. So I'm going to run this. And here you see that I have the first 10 rows. Because the table cannot go all the way, use my whole screen because it's too narrow, it prints, you know, for example here, 1, 2, 3, 4 columns, and then the first 10 items in this 4 columns. Then the next 4 columns, and then the next 10 items, and so on and so forth. Okay? So this is a data set where we have incident ID, dates, locations, area burned, homes destroyed, and so on and so forth. Okay? Now, data is not always clean. Okay? And we're going to clean this data a little bit. For example, in the date here, you see that this date is in a different format, right? That might be one error. There are other mistakes here. For example, in injuries, here, there's a missing value, right? So we have a bunch of phenomena that happens in natural data here. So some is in the wrong format, some is missing, some might be entered incorrectly. Who knows? Let's explore this data a little bit and see if we can spot some irregularities. So this data frame, I can say df to spot the data frame, and I can say, for example, info. So I'm going to print the information of this data frame, and for that, I'm going to go print the df info. Here I have it. So this is the information. There's 100 entries. There's 11 columns. And look at this. We have date is not of data type date. It's of data type string. It thinks it's a string or an object of some kind. And that's not the case. This should be dates. Why is it important that they're dates? Well, because if the data type is date, I can make comparisons. I can say which date is greater than another date, which date happened after or before. I can do operations. So for example, get me 7 days after a given date. With an object, I cannot do that. So it's important that some of these at least have the correct data type. Date is one of those that is not the correct data type. We'll see how to fix that. Another thing is we can see that business destroyed and injuries don't have 100 values. They have 99 values. That means that they have one missing value in them. So we'll need to figure out how to fix these things. Okay? We can also get some statistical information about our data, so about our data frame. So I can say dataframe.describe. This I don't need to print because describe prints by itself. If I run this, look at what happens. I get all the numeric columns and their count, how many records are there, how many rows, their mean value, their standard deviation, the minimum value, the maximum value here, and also I get the 25th percentile, 50th percentile, and 75th percentile of the data. If you don't know what these are, don't worry, we'll talk about statistics in another video. But the point here is you get a lot of statistics. And some should attract our attention. It will, if we look at fatalities, we have really small numbers, at least in the first 10 rows. However, in fatalities, the mean is 11, and that's fine, but the maximum is 190, right? That is weird because the minimum is 0, which makes sense, nobody died. The 25th percentile, so 25% of the data has about 5 fatalities. 50% of the data has between 0 and 10. 75% of the data has between 0 and 14.25. So these are small numbers. It makes sense that most of the data is between, I don't know, maybe 15 or 20, but there's a 190. It's a much bigger number. So that should immediately attract our attention. So we have a few problems here. We have missing values, we have a value that looks suspiciously large, and we have a column, date, that is the wrong type. So let's fix these things. Okay. So let's fix the business destroyed. So for example, one thing that I can do is in the DataFrame DF, I'm going to fill NA, fill non-available values, fill NA, fill non-available, okay? And I'm going to put in parentheses, I'm going to put a dictionary with the column that I want to fill in this case is businesses destroyed. It has to be typed exactly as it appears in the database, okay? And if you want to know how it appears in the database, you go here. You can even copy this and paste it. We're going to make sure, so I'm just going to paste it here instead of writing it up. I got it right, okay. And then the value of this item is what information I'm going to put for the missing values. So what I'm going to do is, if I look at business destroyed, where is that? Business destroyed here. The mean is 251 businesses destroyed. So if I don't know what goes in the businesses destroyed, I'm just going to use the mean 251, okay? What I want to do then is put this thing in place, this word equals true, okay? For now, this is just a good thing to do. I'm going to do the same thing for the other missing values. I'm going to fill NA, and then remember it was injuries, okay? And injuries, what's the mean of injuries? 42.4, so 42. Okay, so I'm going to put the mean injuries is 42, and then I'm going to close the dictionary, and I'm going to say in place equals true. Always put in place equals true for now. If you don't use in place equals true, some other things happen that you will learn later, but it's not very relevant. So if we do this, and I run this code, okay, now these were replaced. And I can see that they were replaced by, for example, doing print df.info again. Okay, so I'm going to print df.info. And look at what happens. I see that everything has 100 non-null values. So I have successfully filled out the missing places. Now, I'm just going to make that go away. Now, remember the date column was an object, and we wanted to make it a date time. That's the data type of a date object that I can use to compare things and whatnot. So what I'm going to do is I'm going to say df, the data frame, the date column. Remember, this is how I selected a date column. And what I'm going to do is I'm going to say, hey, there's a function in Pandas that helps me. So PD is for Pandas functions. PD dot, and then I say to date time. That will convert something onto a date time. What am I going to convert to date time? Well, the column date from my data frame, right? And what am I going to, what's going to be the format? I'm going to say format is mixed. That means it will auto-detect the format. No matter how I put the date, it will try to convert it to a date in some sensible way. And I'm going to close this. So a little bit of analysis here. Remember df date, so the column date in data frame is basically a list of values, okay? So I'm going to reassign the list of values. And what am I going to do? I'm going to take this list of values. I'm going to make them into a date with any format, and that list of this will return, this whole thing will evaluate to a list of datetime values that correspond to those in the date column. And I'm going to reassign them back to the date column, basically replacing the date column with the date time values of the dates that are now object. So I will do that, okay? And then I will print the data frames info, And now look at the data type here. This column is now a daytime. Okay? Now, the other thing that we saw that was fishy is that in the data frame, in the fatalities, all the values were like less than 20, I would say, but one of the values was 100 or some values were 190. So we look at here in fatalities, the 75th percentile was 14.25. So let's select all the fatalities, all the data with fatalities greater than 14.25. And let's see if we find something. So we can do df.query, and then here we put the column name, fatalities. It has to be spelled exactly as it's spelled in the columns. And then let's say fatalities greater than 15 or 14.25. Okay? And then we close this and we run this. Here's the result of my query. These are all the fatalities that are greater than 14.25. And let's see if I can move this a little bit here. And we see the fatalities, 19, 15, 17, 18. Here's my 190, 16, 19, 17. All of these are very small except for the 190. So you know what my guess is? Maybe this was 19 and the person entered it wrong. So I'm going to replace it and put 19 in there. So the first thing that I need to find out is what row is this in? So if I highlight it, it's in row 12. That's going to be important. So let's change it. Let's change it. So I'm going to do df.location. And here's something where I can select the row and the column at the same time. So row 12 and column fatalities. And that is going to be 19. Okay? I will put that. I'll make that change. I executed it, so it made the change, hopefully. Well, let's see if it made the change. Let's look at what the location 12, so column 12 says. Here, column 12 has all these values, but then fatalities is 19. It did change that column. So now we know how to handle data, how to select data based on some criteria. We're going to talk more about that. In this case, we selected data greater than 14.5. And we also know how to repair missing data, some wrong format, some other values. In the next video, we're going to start making plots and doing some data analysis. I hope you like this video and stay tuned for the next one.